figures out which systems in the SUNY system, or which libraries in the system fill the request, assembles the program or the same landing screen, and it automatically gets that. So within a matter of seconds, when someone submits a request, the request is already transferred to a potential landing library. And that automation has made a really big difference in terms of turnaround time. Within ILLiad, typically, for items moving between SUNY libraries, it takes about 8 or 9 days for something you have to find in front B. In Alma, it's only 6 or 7 days. So we have been noticeably faster turnaround times. Also, within Alma, we were able to institute a system-wide 16-week loan period. Whereas in ILLiad, libraries just do whatever they want to do. So that loan period with 3 weeks up to 16 weeks. But within Alma, everybody's getting 16 weeks. So, generally, it's better for our users to say sending requests into Alma, we'll get the item faster, and they'll almost certainly find it on the loan period. Lastly, Alma allows users to manage their resource sharing requests within the ILLiad, so when things aren't in a separate system, we can manage the resource sharing logs wherever we want our or go from your own collection. Another major issue that we're having with ILLiad enrolled shares that it's just no longer cost effective for many of our libraries. As I said earlier, nearly everyone in the system had ILLiad from the first library in Alma. About a quarter of the system has since dropped ILLiad, and a handful of libraries have even taken it one step further to drop ILLiad share as well. To help with our fill rates within Alma, we've done a ton of work with other systems to expand our Alma resource sharing network. We currently have partnerships with the CUNY system, the Connecticut State Colleges and Universities, WRLC, Pascal, FLVC, the Cal State system, Oregon's Cascade, the global consortium, Ontario. This is up here, but we're now working on a partnership with the University of Wisconsin system. And we have just a lot of individual libraries that we're partnering with, like Brandeis University. They were one of our first partners. East Tennessee State partners. So users submitting requests directly to ILLiad, they're having to wait longer, we're getting shorter long periods, and they're subverting all of this work we're doing to expand the network within Alma. And that led to a second question. Is there any way for us to take a request that was submitted in ILLiad and automatically recreate it as a borrowing request in Alma? Another spoiler alert, the answer to that question is yes. So then after we worked through those issues, we started talking about this, and we actually gave the same presentation at the IDS conference this summer. And that led to a third question. Like some of the people in the crowd were really excited about what we were doing, but what they really wanted to be able to do was automate the process of taking ILLiad lending requests and placing a hold on it for a pseudo patron in Alma, because a lot of our libraries, that's how they manage their ILLiad requests. They actually check the items out to a pseudo patron in Alma. So they asked, can you have this add-on automatically place holds for lending requests in ILLiad for the pseudo patron in Alma? And thankfully we actually figured that out too. So before I hand things over to Bill, I just really want to summarize everything that we were trying to do. We wanted to be able to convert an ILLiad borrowing request to an Alma hold request if the requested item is locally available. Convert an ILLiad borrowing request into an Alma borrowing request if the requested item is not locally available. We also wanted this add-on to be able to identify duplicate requests and requests for ebooks. Both of those things are issues that are time-consuming for our staff to deal with. And then lastly, we wanted to be able to place hold requests in Alma with ILLiad lending requests. And the ultimate goal was to reduce the workload for libraries, staff, provide faster service to our users, and then ultimately help us reduce the research sharing expenses. So I'm going to hand things over to Bill.
Thank you very much, Tim. Hi everybody, I'm going to tell you about the unintended journey that we had developing this add-on. And as Tim had said, it all started as a hold request for add-on. So here's beautiful SUNY Geneseo campus. And you're probably familiar with that, environment up top where we've all been living for the past, I don't know how many years, but there's Tim and Angela and I, and Tim says, hey, Bill, do you think we could send a hold request from Alma to ILLiad? Or should be from ILLiad to Alma? And I said, yes, of course, I will do the thing. That's a WGSU on campus, our local radio station. And then later that semester, this is a picture of my son going down the slide, right? And I'm just gonna take a quick tangent really quick, kind of describes about our development process though. I mean, how many of you I'll take care of kids, right? Like you watch them go down the stairs for the first time and they don't just like walk, they like go back to the thing. And William's going down the slide and I'm like, what are you doing? Yeah, learning to go down the slide, right? So a lot of these things were like brand new to us and we had to learn them and so that was kind of felt like the development in a way. And so later that semester, Angela said, hey Bill, I have a better idea. Do you think you could make it so we could send a form request to Alma from ILLiad too? I said, absolutely. Yes, and we'll make it with love. There's a breakfast. That's Lego there too. Big Lego fan art. So this add-on that we're going to talk about, I just want you to keep in mind that it's available. You could have it just submit hold requests, submit bar requests, or do both hold and bar requests. So our development timeline, we've almost been working on this for a whole year now. It started November 3rd of 2023. We meet about every Friday. We try not to let it interfere with our lunch breaks. We have this running joke about Stewart's shop and Tim getting his sandwiches there. But we continue to meet weekly to enhance this add-on. So the system requirements for this are you need to have access to the ILLiad customization manager, you need to have Alma User API with read and write access, and you need to have the Alma SRU lookup enabled. You also need to have the bids API read access, which I forgot to put on this slide. They're very easy to request. You just go to the Alma developer network. Whoever's your administrator can request those APIs for you, and they're very easy to use. So there are three different types of add-ons. We're going to be focusing on the server add-on today. Just to go over those three different kinds. There's the client-side add-on that you can see in the transaction view, that you can see those different tabs and help gather data. There's a system add-on that has registered event handlers that you would click a button and it would create something that would happen. This is the NSIP add-on. That when you click that checked in, it sends a message. That's an example of a system add-on. And the server add-on is one that runs every X minutes. So you can set this in your ILLiad customization manager. It's in the system manager add-on interval. So at Geneseo, we have this running every 2 minutes. So the add-on is just continually running and looking at a queue or multiple queues for analysis. Here's a poor library joke. Just improving my H-index on this 2014 presentation I did with Hank Swain at a Lookup conference. Some of the techniques that are used in this add-on were used in the NSIP add-on too, particularly using the web client and sending the XML messages to be able to create this magic. So we're not talking about something in like theoretical terms. This is actually what the server add-on looks like. Comes in a zip folder, and there are currently 6 files in there. You've got the Google file that has your code, and then an XML configuration file that stores all your individual configuration values. And then we've got some specific documents that will help make decisions for you. So if there are particular errors that you want to handle in a particular way, you do error routing. If there are excluded locations that you wouldn't place holds on or allow borrowing from, you can put those on that excluded locations list. You can look for particular process types like missing or in binary, and maybe you want to handle those and route those to a particular queue. And also a sub-libraries document that will help do a crosswalk between the NVTDC and ILLiad and the Alma pickup location, I believe is what that sub-libraries does. So here's what those files look like. This colorful one over here is the Google file. Here's your configuration, and then you've got these different text documents that you could add your configuration. How do you install it? You just get into your customization manager and you just upload that zip folder after you've made some configurations. You can make the configurations directly, with those text documents, you have to edit those manually. But in that configuration.xml file, you could make those configurations right here in the customization manager. So currently there are 21 configuration values for this add-on, which I understand is quite a bit, but we kept adding more and more things to it, and we found that these things were necessary. The most recent one is that ultimate debug down at the bottom that will leave very useful notes in the transaction. Figure out why isn't it working or why isn't it behaving how you would expect it to. It'll leave links for your SRU lookup or even your bibliographic lookup, and we have found it to be very useful for troubleshooting. So how does this work? From a simplified perspective, it looks at an ILLiad queue and it checks local availability using an SRU lookup using the ISBN or OCLC number for borrowing loan transactions. Now on the you're right. If it's owned and available, it's going to check and see if that user has that loan out already. So you don't want to be making duplicate requests. Let's say they haven't checked that out already. If it's physical, it'll automatically attempt to place a hold request in Alma, and that patron will get a message and it'll print out the slip on your printer, and then it'll route it to a success queue. Now, if it's not available, it will route it to a failure queue. If it's an electronic item, it'll attempt to add the URL to the ILLiad transaction and then route that to a success queue in ILLiad. Otherwise, if it's not available, it'll route to a failure queue for review. Now, what's really cool about adding that URL is that if you use those email templates within ILLiad, it automatically send that message to your patron, letting them know right away that it's available. Now, let's say that the item is not owned and available according to SRU lookup. It could try to automatically submit a borrowing request to Alma. And then if that's successful, it'll route to success queue in ILLiad, which is completely configurable to you. Or if it fails for whatever reason, there's a myriad of reasons it could fail, it'll route that to a failure queue. So the first step is, did we already touch this transaction? And we've got this, familiar with Lord of the Rings, you've got Bilbo and Samwise Gamgee there, and they're walking around the Rocky Mountains, and he's like, I think we've been here before. And he says, it's because we have been here before. We're going around in circles. And we found that the add-on was doing this, and we wanted to find a way around it. So we added a note to the transaction, and if it finds this note in the transaction, it will route to a failure queue. So it's not just continually trying to process that transaction. Then we can figure out, why did it sit in that queue, or what happened. Then, if there is an ISBN or OCLC number, is that ISBN valid? So sometimes users, or systems, they put weird information in the ISBN field, right? Like, I've seen some very strange things, and I'm sure you have too. So if there's an invalid ISBN sent to the SRU call, it'll send back an error. So if the ISBN is present in the request, the add-on will try to mathematically validate the ISBN, which is pretty cool. We're going to talk about that in just a minute. And if it doesn't validate, it's going to try to extract an ISBN from that field. And then it'll try to validate that extracted ISBN. Now, if there's no ISBN and no OCLC number available in the request, it will route that to a failure queue so that you can review that. So this picture here is trying to demonstrate two different systems communicating with one another. There could be, multiple reasons. Maybe there's an issue like with one system communicating together. Maybe it's just an issue with the system itself. You can see in the bottom, it's just not able to spit out those numbers, right? Like, what's the issue? Don't know. So here's our case study on ISBN validation. Angela said, you got this really weird ISBN value, you can see highlighted there, and it came back as an invalid query. Like, invalid. So that means it has to be valid, right? Like, there has to be some kind of validation. So I got on the hunt for what makes an ISBN valid. And so I started to research, and I found that there is actually a mathematical formula for these ISBNs that validate. I'm not going to read all of this information to you, but I think what's really interesting is that in that bottom paragraph, an ISBN is an international standard book number. ISBNs were 10-digit in length up to December of 2006, but since the 1st of January 2007, they're now consistently 13 digits. ISBNs are calculated using a specific mathematical formula, and they include a check digit to validate the number. Anybody know that? I had no idea. What? They're like sitting around cooking this up, right? Like, so what is the math behind it? So here's how it works for the 10-digit. There's two different flavors, right? There's 10-digit and 13-digit. So you take that first number, you multiply it by 10. The second number, you multiply it by 9. Third one, you multiply it by 8, so on. And you add all those things up. And then you have to divide it by 11. And if the quotient is 0, then it's a valid ISBN. You might be wondering, what's that x? Well, the x is 10. So that check digit makes it so that it actually makes that math work. Now, what about the 13-digit? Well, you take the first number, you multiply that by 3. The second number, you multiply, by 1. The second number, you multiply that by 3. The third number by 1. 3, 1, 3, 1, 3, 1, right? Go all the way down the line. And then you divide that by 10. And if the remainder is 0, it's a valid ISBN. This percent sign here you can see in the bottom is actually called a modulus. That's a special function that is what is the remainder. That's pretty wide, I think. So still we can validate that ISBN, but then Ron at Syracuse said, Bill and Tim, we're getting these words in our ISBN field. How can we handle them? It's just saying that it's not valid. What can we do? So we found a way to extract this, and it kind of runs in this pattern, right? It tries to extract a 13-digit string. Or if you can't find that, 12-digit plus an x or a lowercase x. If you can't find that, try to find a 10-digit number. If it doesn't find that, it'll find a 9-digit number and then x or lowercase x. And then it will try to validate that number again. I think that's pretty good. So we have a good ISBN now. What's next, right? Having a right number is important. And I found this picture and you just like play along with it really quick. Hey, Bubba, there's spaghetti in the fridge. Garlic bread wrapped in foil. Wrong number. Dang it! Who's gonna eat this spaghetti? I don't like spaghetti, right? Like you want to have a valid number, it's really important. And it's important for these requests. So we've got a valid ISBN, and now we have to see if it's available or not. So we'll use the ISBN or OCLC number, and we'll do an SRU lookup. SRU lookup stands for search and retrieval or via URL. This is really cool technology that actually was developed. And this is how it works. So you've got these three configurable values within this URL. You can plug this URL right in your browser, and it'll return mark XML. Well, yeah, it's similar to mark XML. So you've got your base URL, you've got your institution code, and then you've got the number for that item. And what does it look like? This is what it would look like if you put that URL in there. It'll give you all those bibliographic records, or the bibliographic record, and then it'll give you some holdings underneath it too. So what does it look like if you put an invalid ISBN in SRU lookup? Well, you can see on your left, there's that one from Angela, and it came back as invalid. Well, look at these ones. Like, have you ever seen an ISBN like that? No, but it doesn't return an error. So it's like, what? I don't understand. So all of that research that we had done before, it mattered and it kind of didn't. It matters in terms of like automation and efficiency, but it actually does accept invalid ISBN. So is there an ISBN tolerance for Alma? I mean, a little bit. It appears that with the user's API, it'll accept almost all alphanumeric strings. The user's API will not accept malformed URLs, which was the problem in Angela's case. It had a comma and a space. And that space is what broke the URL. So we have a space in the URL. Broke, it will not resolve. So how can you turn on your SRU lookup? It's super easy to do in Alma. You go to your configuration, general external systems, integration profiles, and you add an integration profile. Here's that screen right here. One of those options is that SRU server. You can give it whatever name you want. We chose those names. And then you can set what kind of bibliographic options you want it to return to, and you can password protect it if you're, should I say paranoid? I don't know. Maybe you just want to protect your data. But there actually was a request from Syracuse to have this working, and that was another tricky piece because I had never sent a username and password in a request. It's actually pretty crazy how it works in some of this like base internet technology. Like it takes that username and password, it puts a colon between them, and then it encodes it in base 64, and that's sent in a header. It's like, what? So if anybody do that and they were using that technology, you could use that base 64 and decode that. It just got me thinking about it. Does 21 passwords? perspective, right? So analyzing the SRU lookup to determine availability. Here's that AVA tag, and that AVA tag means that it's a physical item. And this exists underneath all that bibliographic information. So you can see the MMS ID, that's that unique ID for that item. You can see the shelving location, and you can see the availability for the item. And then we can use that to help determine how we want to handle this. It's going to give you two different tags depending on what type it is. It's going to have an AVA tag for physical items and an AVE tag for electronic items. So I was under the assumption, which was an incorrect assumption, that libraries had the direct target URLs for the items in the 856 subfield view. Not true. It just so happened to be true for Geneseo for 40,000 titles we had purchased from Springer Link that they had written them in this. So in my testing, it was like, yeah, we can just grab that 856. Well, it turns out it only worked for Geneseo. But there is a portfolio lookup that is available in Alma that we're going to be adding to this, so we can add that URL. Still, very cool concept, and we will get it to work. Then Angela asked, well, what if I want to have electronic overprint? Could I do that? We're like, yeah, sure. So all Angela has to do is check a box and say, I prefer electronic overprint. It'll do an AVE lookup first, and then the AVA lookup, all dependent on your workflow. All right, now we want to filter through those results. Remember, we had that excluded locations list. Maybe you have a special collection that you wouldn't put a hold on, or maybe, I don't know, for whatever reason, you wouldn't put a hold on these items. You can actually list those locations in this excluded locations.txt document, and then it will leave a note in the transaction letting you know that this was not able to place a hold request because you don't place holds on those items in those locations. Yep, if the item is in a location on the excluded list, a note will be left with the name of the excluded location, and the transaction will be routed to a review queue for items belong in an excluded location. A note will be left in the transaction with the excluded location name. This excluded locations file works for both physical and electronic items that come back in the SRU lookup. Another thing we found that Angela wanted to handle was particular process types. So maybe something had just gotten ordered and they still wanted to be able to place a hold request, or maybe it was being fixed. It was like work order department. And so in this document, you can write that actual process type value and then route it to a particular queue that you would like to. Now, we didn't want to keep placing a request on something that they had already requested. Angela said, somebody's requesting 7 copies of, I can't even remember, it was some crazy movie. Was it Roadhouse? I don't know what it was, but for some reason this person wanted all of the different versions and they wanted to catch that. So we do a lookup and you can see a Wes Anderson film. Okay. So you can see all of the requests using this, a retrieve users loan call from the users API. Now what's interesting about this particular API is it will only return 50 records at a time. So we were like, she said, well, there's one request that has like 120 requests or items checked out. And so we were like, well, you could, sort it ascending and get the first top 50 and then sort of descending and get the bottom 50, and then you're kind of left with that 20. But I mean, what are you going to do, right? We did the best we could. Usually there's not that many requests, but for some, as you know, the patrons will have over 100 requests there, or loans, should I say. So here's an example loans API return. You can see that it'll have the MMS ID within that. And if the MMS ID matches the MMS ID that came back with the SRU call, it'll be routed to the failure queue. It'll say, hey, this patron already has this item out on loan. You don't want to go place a hold request on that. So now we're at a crossroads. It's either the item's available in your library, you can place a hold request, or it's not available and you want to borrow it from somebody else. So if it is available in your library, this add-on will automatically create a hold request within Alma for you. If it's not available, it will create a borrowing request in Alma. Now I'm going to tell you how this works. How do you place a hold request in Alma using a web API call? Use the Alma Users API to send and create users requests. The documentation on the Xlibris website is phenomenal. You can test out your APIs right there. They'll show you the failure returns and all sorts of different information, and their tech support is phenomenal. Here is the structure of a user's API call. So you would connect to this URL with those configurable values, and once you connected to that URL with that web client, the add-on, you send it as little XML chunk. And so it's going to contain the pickup location type, the pickup location library, and the pickup location institution. That's really all you have to place, all other than the request type as a whole. There are a couple different request types, but we're using whole in this example. And I just like, why didn't you put that in the URL? It's not that many values, but I'm not going to place any judgment here. That's what they chose to do, and there has to be a good reason. So to build that XML, it uses configurable values. These values would be in that sublibrary.txt crosswalk that you can type right into, and that way it just plugs those values in to send that XML message to place that hold request. So how does it send the hold request? It uses something called a web client. This is like a Microsoft library, I believe, and you can embed that right in Lua. And so it creates that web client, and it sends that. It connects to that URL and sends that XML package up to it to place that hold. And this is what it looks like once successful. You'll get user requests at the top of that stack there, and then information about that item to let you know that it was a success. And here we are in Alma. You can see too, it creates it right away. There's the hold request, and then a piece of paper will come out on your printer if you've got that set up. Now, what does it look like if it fails? This is in Postman, which is a really useful tool for anybody who's interested in trying out APIs, because you don't have to really have any coding knowledge. You can just plug this stuff in. It's a free service. It was instrumental in making this add-on work for us. So you can see here in the bottom, it says failed to save the request. Patron has active request for selected item. This was an example of why we would want to look and see if that user already had that item out on loan, because it will fail if they do. We wanted to catch that beforehand. Now, to my own ignorance, I was like, well, Tim, can you send a hold request on an electronic item? Can't you do that? He's like, no, you can't do that. But the return will let you know that too, right? This is the failure of an electronic hold. It says no items can fulfill the submitted request. I'm just in the mindset of like, hey, anything's possible. Can't you do that? But you can't place a hold request in an electronic item, and you will get a failure. You can also see that there's a particular failure code there, 401129. There are many different failures. Now, if it's a success, it's just going to have that user request tag right at the top. That's really the only thing we're looking for to determine if it was a successful holder. Now, here are all those different reasons why it could possibly fail. This is all in the Xlibris documentation. Looks like there are, I don't know, maybe 18 different errors that could possibly come back. Some of them make sense. Still a great list to have, and you can handle these particular errors in any way you want to using that error routing document. So again, going back to kids, you've got to know like what that behavior is, right? Take care of that person. You can't handle every single negative behavior in the same way. You can't stick them in the corner every single time, right? Like you got to talk to them. You got to maybe show them why that was a bad decision. So same here, you can't treat every error the same way, and so that's why we had that error routing document. And those errors come back as part of the whole. So the add-on automatically routes the transaction to a configurable item fail hold request queue if the error code, remember we had that list of error codes, if it's error code 401136, and that says failed to save the request, patron has an active request for selected item. A special file is included called error routing that allows staff to create comma-separated lists of error codes and ILLiad queue names in order so that you can handle those particular errors or in specific ways. Okay. So what happens next? If the hold request fails, there's two possible routes. You can choose to have borrowing requests enabled, meaning you can submit borrowing requests, or if you don't want to, that's fine too. But if it's enabled, it'll try to submit a borrowing request. If sending borrow request is disabled, it will send that transaction to the failure queue, so you can take a look at it. So now we're going to talk about how to place borrow requests with the Alma Users API. Again, documentation on ILLiad is great. This uses a different call called the create user request for resource sharing call. It's slightly different from the hold request, and then it has a little bit more information in that XML. You're going to need information about the item itself, and then you're going to need to know what the location is, what the type is, and you'll need a title. You'll need some kind of information. This was the bare bones message that you needed to have in order to send a borrow request. Just a title. You don't need to have an identifier or author or anything like that. Good. So this is how we went about building that XML message, because we can have all those values in ILLiad to be able to send. But sometimes those values aren't filled out in your ILLiad transaction. So for us, the pickup location type will be library, unless the pickup location is home delivery or office delivery. The pickup location libraries come from that crosswalk document, that sublibraries.txt crosswalk. You can also send notes from the original ILLiad transaction, and you can send bibliographic information with that too, and we'll try to clean that up. I'll tell you why in a second. So, what if your patron left notes behind in the ILLiad request? You're like, I wanted that red book with the gold gilding. Let's copy that note and send it to the borrow request. And then what if it fails in ILLiad? Well, that note will come back. I think that is so cool that you can do that. So here's an example of that. The note has a note left from the patron and a note left by ILLiad when the borrow request was sent to Alma with the original ILLiad transaction number. When the request was not able to be filled with Alma wrote us, it went back to ILLiad as the general electronic service in Alma, and it carried both the note from the patron and the note from ILLiad. So you can see here it says, note, ILLiad TN 1283094, note from patron. This is a note by Bill Jones. Test. That left ILLiad, went to Alma, and then came back into ILLiad. You can know that this was already in request. And the reason we had to do it is because it can't go back to that original ILLiad request and keep modifying it. It had to create a new request. Now remember I talked about cleaning up those characters, or those values within those transactions. Angela was like, these requests are failing and we don't know why. And it turned out that there were diacritics and there were other, well, first there were these values, right? You can't have double quotes or single quotes or greater than or less than signs or ampersands. So I created a small little function that would replace those with an acceptable value to be sent. And we also found that there were diacritics that were creating issues too. And the key to solving this is in the header, you set it to char set equals UTF-8 in the content type and the accept. This one took a little bit to solve, but then I remembered 10 years ago I had this same issue when I was working with Hank at Harvard on the ENSIP add-on, and it was breaking and we couldn't figure out why, and it took like, I don't want to tell you how many hours it took, but this was the solution. You had to set that header here and then this char set to be able to handle those. Now, this is handling a successful borrowing request. It has that tag. It says user resource sharing request. That's just letting us know that it was a successful call. That's all we have to look for in the return. And a slightly shorter list of failure reasons. These are particular numbers that could come back if it did fail. So you could say the institutional inventory has services for the requested title or general error. But you can handle those in a specific way with that error routing document. So the behavior management here, the add-on will automatically route a TN to a configurable item fail queue if the error code is 401873. This is all it would leave. It would just say 401803 failed. And after multiple tests, we found that this was because they already had a duplicate borrowing request in Alma. It will not allow you to submit a duplicate borrowing request for that user. So you can, it's handled specifically hard-coded in the add-on, but if you came across other error codes, you could route those to specific error queues. If you didn't have that configured, it would just put it in a general failure queue. And so as Tim had mentioned, in July 2024, we presented about our borrowing add-on at the IDS project conference. And then during the question and answer portion, people were interested in transforming this borrowing add-on and making it work for lending requests. So as Tim had said, libraries have been manually checking out items out to pseudo patrons. Those are like fake accounts in Alma, and they wanted to automate putting these items on hold for the pseudo patron. So a few months ago, we started developing a lending add-on, and it's now being tested at Albany, and it's working successfully. The add-on will allow staff to check out lending requests to one pseudo patron account, or if you have individual accounts for each institution, which would take a considerable amount of time to set up, but if that's something you did, you can list those OCLC symbols and then their Alma user pseudo patron name, and then check those out to those individual institutions. We'll put a hold on them, I should say. So our future plans, we're going to continue testing this add-on at the University of Albany, Upstate Medical University, Stony Brook University, and Syracuse University. We'll begin testing at Binghamton University and University of Albany, and we're also looking for additional libraries to test these. And just some of the tools, in case you want to go try to write some code yourself, or use the code that we have and modify it. Postman is an excellent resource to use that allows you to do those API tests. Notepad++ is a great Windows text editor that allows for coloring for specific codes. And then Beartail, which I was told at one conference is deprecated, you shouldn't use it. There's like a better software to use. But what this software does is it allows you to open up that ILLiad error log, and it'll keep it running, and you can see the errors that are coming up in that log instead of opening that log every single time that you want to see what the new error is. And now I'm going to hand it over to Tim.
Thank you very much, Phil. So to wrap up, I'm going to talk about how things have been going at the University at Albany since we first started testing this add-on. And they're actually using two different instances of the add-on, because one potential issue is a user submits a request to ILLiad. The request gets duplicated or replicated within Alma, is immediately unfilled, and then exported as a brand new request back to ILLiad. So we wanted to avoid a scenario where if the item wasn't available at any of Albany's Alma partners, that they would just be duplicating the request. So the way we have things set up there is a version of the add-on that's creating just hold requests, monitoring a queue. If the item is locally available, the hold request is created. If it's not locally available, then it's sent out through OCLC via direct request. And they have direct requests set up to kick back requests for items that are available at one of their Alma partners. Those end up in a queue in ILLiad. And then the second version that only creates borrowing requests is acting on those. So far, since we started testing this, they've received 2,300 requests via ILLiad, and they've managed to move about 15% of them over to Alma. They've also managed to identify some that are available as ebooks, some items that are held on course reserves, and they said it's really been helpful and helped reduce their workload. A couple of challenges, like they can't reactivate the original request in ILLiad if it goes unfilled in Alma. Like I said, a duplicate request would be created. I'm going to pass through some of this stuff because I know we're running short on time. I think we've talked enough about the lending workflow as well. So I just want to go straight to where we've been sharing the add-on. So it's been uploaded to GitHub. Once it's being tested at more institutions and we're confident that it's ready for wider consumption, we're going to add it to the ILLiad's add-on directory. And this last part was for just some libraries that were interested in using this. So that's everything we had to talk about. So I'm going to open things up for questions.
If your library might be interested in testing or helping partner with this, but you have no knowledge on back-end development, is this something you would still want us to reach out to you about?
Yeah, absolutely. Yeah, you don't really need to know, I mean, there's. Other than obtaining the API keys, and just installing and configuring the app, there's really not much you need to understand on the back end of things. Angela?
Yeah, this was the, probably really wrote, systems librarian,
Oh, I'm not either.
so one of you is. Yeah, from the sandbox perspective, you have that area for testing, but from an ILLiad perspective for testing, how are you able to test without interrupting your services?
Well, the add-ons can be configured to,
Oh, I'm sure, no, there's all the sandbox where I know that you can test, but for the ILLiad side of it, how are you able to test without interrupting your services, especially with the staff?
so the add-on is configured to look at very specific queues in ILLiad. So what we've done is just we've created these test queues that the add-on's looking at, and then we're just manually creating test requests routing to those queues. And it's not touching any, or at least while we were still in the testing phase, it wasn't touching any of the regular requests that were in their normal statuses.
Okay,
So
so I'm sorry.
Oh yeah, you can really target this add-on and have it look at a specific queue in ILLiad. So as long as you're not looking at like awaiting request processing or anything like that, you're okay.
So it's a combination of premium sandbox and production ILLiad instance.
Yes, exactly. Oh, although it's worth noting that all the testing was done in Albany's production Alma. They actually don't have the sandbox.
And you were always able to do that without interrupting.
Yep. Yep.
Thank you.
Any other questions? Sure.
Were you already using lender of last resort beforehand? It just felt like, I mean, I may have missed at the very beginning. It just felt like it didn't address enough of the wants.
Yeah, we are using lender of last resort pretty widely in ILLiad. But what we're trying to do here is deal with the requests that are never submitted to Alma in the first place. The stuff that just got dumped straight into ILLiad. So what we would do is, use the add-on to essentially pull the request out of ILLiad, replicate it in Alma, and then if it goes unfilled, then the lender of last resort functionality would kick it back over to ILLiad, and then you would just fill it as you want.
Thank you for reminding me. So this works in tandem with ILLiad.
Yes, yep,
Lender of last
Yep.
resort.
all right, doesn't look like we have any other questions, so thank you very much.